Hi. From a young age, children are taught the basic colors, such as red, blue, yellow, etc. It isn't until around the age of 5 that they start showing the signs that could represent color blindness, and parents can pick them out by realizing that children aren't only just mixing up their colors, but may not be seeing them correctly. Color deficiency, otherwise known as color blindness to most people, only occurs in 5 to 8% of men and 0.5% of women, which equals out to about 1 in 12 men and 1 in every 200 women. It also has many different causes, which includes genetics. There are 4 main spectrum deficiencies. However, red-green is the most commonly known. For more information, you can check at colblinder.com. Inside the human eye, there are different types of photoreceptors, both rods and cones. Located in the retina of the eye, there are about 120 million rods, which perceive light in its varying degrees, and only 6 to 7 million cones, which carry the different colors perceived in the light back to us, allowing us to see them. There are 3 different types of cones: the S cone, the M cone, and the L cone. For more information on the cones and rods, please visit colorvisiontesting.com. The first deficiency is protanomaly, which is a red weakness affected by the L cone, which means it could be the cone itself could be deformed or missing altogether. For most people, this just means that you have a harder time seeing that color or varying degrees of it, but with some other people, it may just make that color be missing altogether. A great example of this would be looking at a sprig of purple grapes. Someone with red deficiency might see them more closer in relevance to the color of blueberries. The second is deuteranomaly, which is a green weakness affected by the M cone. Many times, deuteranomaly runs hand in hand with protanomaly, creating what is commonly referred to as red-green colorblind. Also in this category falls dichromacy, which is where a person can't distinguish between the color hues red, orange, yellow, and green. Even though this may affect the person on every day, like their daily lives, it is so rare that it only affects maybe 2% of the population that even have the red-green colorblind. The third would be tritanopia, which is commonly referred to as blue-yellow blindness. It is much like the other ones, except for it's caused by the S cone, and can just as well be the color missing altogether. A good example would be if you looked at the bottoms of all colored pencils lined up, they may not see all the different colors, but they're going to see basically a greenish or a red color overall, as opposed to anything else in the spectrum. The fourth deficiency is the most rare and the most difficult to deal with for many people, and that is monochromatism. Monochromatism is where there are no cones, or possibly maybe just one, in the retina of the eye. And this makes it so you don't see color, but where most people would say the term color blindness was coined, where you're only seeing varying degrees of the shade of gray. Among these 4 deficiencies are many subcategories and ways to break them down. For more information, you may visit medicinenet.com to see a further breakdown of them. A majority of people believe that when a person is colorblind, that they can only see different shades of gray in lieu of the color that they are missing, or that they can't see any color whatsoever. The only correct form of that is the monochromatism, and the rest is just varying degrees difference of what you see. If you'd like to find out more on this, or possibly try to test yourself, you can do so at luminosity.com. Thank you.